In this section, we're talking about Ingress. The Ingress is basically a router that receives external traffic that comes from, let's say, the internet, and enters the Kubernetes cluster. And now the problem or the challenge is, how would you distribute incoming traffic to your applications? At some point, you have to decide what domain is mapped to what application. And the way an ordinary or average Kubernetes cluster is built and organized is that you have a Kubernetes cluster, and in front of the Kubernetes cluster there is a load balancer. Let's for example, on parse99s.com we have a EBS, a ELB, an elastic load balancer from Amazon, and this elastic load balancer is shared for at least for the low tier Kubernetes clusters. And this load balancer takes the incoming traffic and passes the traffic based on the virtual host, so basically on the DNS name, to the right cluster, and there is another proxy which is called the Ingress. For example, in our case, it's an Nginx Ingress. So it's basically an Nginx reverse proxy that will then distribute the incoming traffic to a service. So the main takeaway here is you're not exposing a Kubernetes service to the outside. You're using the service to get a stable network identity for the use within the cluster. And in order to create an entry point to your cluster, you're using an Ingress. So in this case, you have like several layers of load balancing. So you have the load balancer that's in front of the Kubernetes cluster. The load balancer could be dedicated to one particular cluster, or like it is in our case, shared among a set of clusters. Your Ingress then is, you could have multiple Ingress controllers, but let's say you have one, for example, the Ingress, the Nginx Ingress controller, and this creates another layer of load balancing, so to say, dynamical load balancing that takes the incoming requests and potentially terminates the SSL certificate, and then balances and distributes the requests to the service, which in turn will introduce another layer of load balancing, unless it's a headless service, which we'll cover in a later section where no load balancing is performed. So there's a lot of load balancing going on, and the reason for this is to take care of the dynamics that run with or that happen within a Kubernetes cluster. So you can see that changing replica sets and changing pods and changing deployments, they all go down to changing pods. Changing pods means changing IP addresses, so you need a stable network identity, which is the service. So in order to terminate the SSL certificate, you need an Ingress, and also to map the incoming traffic to the right pods. That's the purpose of the Ingress. Sorting incoming traffic to the right pods. The load balancer that's in front of the Kubernetes cluster has the purpose of, has the responsibility of distributing incoming requests either to different Kubernetes clusters or across different ingresses of a Kubernetes cluster. So it really depends on how the Kubernetes is set up. There's a certain degree of freedom when you design Kubernetes-based products and platforms, but that's basically the structure. So you have a load balancer outside of the Kubernetes cluster, you have an Ingress inside the Kubernetes cluster. The Ingress passes then traffic to a service, the service passes then traffic to a pod. If the service is headless, there's no load balancing, but just a DNS entry. We'll cover that in the stateful set chapter in greater detail. All right, so the Kubernetes service, that's maybe a good thing to say, is a layer 4 service. So if you look at the ISO-OSI, the ISO-OSI model, then a Kubernetes service is on layer 4, where an Ingress is on layer 7. So the layer 4 is about, let's say, TCP and UDP traffic, and a layer 7 load balancer is about HTTP and HTTPS, which would be HTTP and SSL encrypted HTTPS. All right, the main difference between a layer 7 load balancer and a layer 4 load balancer there is that the layer 7 load balancer inherently understands HTTP, and therefore also is able to inspect HTTP requests. For example, the allocation of incoming requests to a particular pod requires reading the virtual host. So in many cases you have a single IP address for your load balancer that's in front of the Kubernetes cluster, which then takes the incoming traffic and forwards it to the Ingress. So, but the cluster may manage several out-facing domains. So for example, you could have example.com and example.org. There would be two different domains. If two different domains point to a single web server, a virtual host concept is required, which means that the web server reads the HTTP header where the host field is contained, and uses that URL to map to the particular and the correct backend. So if you remember, like in the kubectl proxy example, I used a plugin to modify my request header to give it the right host, because we use virtual hosts to map the right incoming traffic to the right cluster. So in Ingress you have a similar ability, but it is built into the Ingress, so you don't have to modify your header. So because for an external domain, for example, the public domain of the cluster, which would be, I'm sharing my screen. Which would be this one. So in order for this to work, you must have a DNS entry, which means I can resolve this to an IP address. So you can see here's an Any9's router in front of that. That's the load balancer I was mentioning. So what you can see here is that the cluster domain is a publicly available domain which can resolve to an IP address. The Ingress will then will receive the incoming request, which I can use in my browser too. I don't need to modify, oh, not this one. I don't need to modify my header in this case, because I'm not trying to enter an IP address here. I'm not trying to enter a URL here, which will then point to my local host. So there's multiple ways on how I can achieve this. If I want to have a URL point to a specific IP address, so for example, when I'm using my reverse proxy, then I would like to point all my requests to a local host. But I don't want to use the local host domain, because the Kubernetes cluster expects this domain. So that's the problem I had earlier with the local proxy, with the reverse proxy. So I needed to modify the header and send the host in the HTTP header, although I'm actually issuing against localhost. And the reason why I had to do this is because my localhost doesn't, because this URL doesn't resolve to localhost. It resolves to this IP address instead. That's why I needed to modify my header. In the case that I'm issuing against, or I'm requesting against the actual IP address, this one, I don't need to modify my header anymore. All right? It's a bit confusing, I know, but whenever you you want to take control over the virtual host, but you would like to control the IP address you're targeting, and this diverges and does not work with your official resolver. So my local macOS, for example, it uses this file. So here I have a local DNS server, which will then resolve to, I don't know, a Google DNS name server. So another way, if you don't want to modify your header, how you could get around that proxy problem we had in the past would be to modify your resolve conf and add this IP address, this URL here, to this file, for example, with your local host. This would do the same, well, let's say it would do the trick differently, but with the same effect. Because then your local machine would resolve this IP address to localhost. So I don't need to modify the header. So there are several ways you can do that. Each solution is a bit of a hack, so it's not really beautiful, but you'll get the point. So back to Ingress. So the idea is that the Ingress uses a layer 7 load balancer, which introspects the HTTP request that will take the header information, in particular the host argument, which will be our cluster domain in this case. If we want to, for example, add another domain, a custom domain like example.org, we need to create a DNS entry or a CNAME so that the example.org IP address points to the same IP address than this one. So either I look up the IP address, so by resolving, for example, my cluster domain, and I create a record for my domains, example.org, pointing to this IP address. This is basically how you make a domain point to an IP address using an A record. So you need a domain name provider that allows you to create A records. Or you create a CNAME where you can reference your example.org domain to whatever this domain is resolving to. It's basically like an alias, if I remember that correctly. So this is the thing you'll always have to do if you want to map a certain domain to a particular endpoint. You'll have to create DNS entries, either a record or CNAME record, for example. The Ingress will then read their HTTP request, and you need to tell the Ingress, well, you are responsible for a particular domain, so that the web server can say, all right, I'm responsible for this domain, and then you need to tell also which domain is connected to which application. So the incoming request will be read. You take the host argument, which would be, for example, our domain here, or your example.org domain, and then you have to tell the Ingress to which applications to point to. And we are not pointing to pods because of the problems with changing IP addresses we've seen earlier. Instead, we are pointing to a service, as we've seen that a service is a stable network entity. So the Ingress connects to a service, and the service connects to a pod. It's a bit complicated, but if you really think about it, it absolutely makes sense, because there are different changes you would like to be resilient against. So the pod changes, you use the service, and then the entire Ingress thing is a mapping to particular endpoints. You don't want to deal with particular pods on the level of ingresses, So using a service as an intermediary a layer is good, because all the Ingress has to care about is which service to point to. All right, so that's the purpose of the Ingress. Do you have questions so far?
So far, no question.
All right, so you understand load balancing, Ingress, service, pods. Okay, you know, Ingress, in contrast to services, to pods, to replica sets, deployments, Ingress is not built into Kubernetes. Well, it does specify how Ingress should look like, but it doesn't ship with an Ingress per default. There are Ingress implementations available, and if you want to configure your own Kubernetes, then you need to decide which Ingress to use. You need to configure it, and only after configuring your Kubernetes cluster with a particular Ingress controller, an Ingress is available. If you're using an out-of-the-box Kubernetes, such as Any9's Kubernetes, or you go to Amazon and take their Kubernetes, or you use kops to create your Kubernetes, it is very likely that these packaged Kubernetes, also Minikube, for local deployments on your computer, that they will all have an Ingress configured for you. But as the Ingresses actually underneath, they do a reverse proxying, and that this reverse proxying can be configured in several ways. There's certain heterogeneity, so that they can be configured in a different way. They may require different annotations. So this is a part where just cut and paste from this tutorial may not work, because of the underlying complexities, and because of the fact that Ingress is not well, let's say 100% harmonized built-in feature, but you'll have to look up into what is the particular Ingress your particular Kubernetes is using and how it is configured. So make yourself comfortable with the idea of reading a documentation when it comes to Ingress.